Bismillah ar-Rahman ar-Rahim. Good day, everybody. Marhaba. We'll start our class now. If you can hear me, everything is good. The voice, the listening, everything. Just put something in the box like this that we can start like this way, so we can start the class. Everything. If you can hear and everything is good. Okay. Wa alaikum assalam. Okay. I'm waiting for the confirmation so I can start the class. You all have my voice, right? Can you listen me? Can you hear me? Okay, just you didn't understand. Never mind. Okay, something that we started, I just review from the last week. Something that we started to talk about was the terminology of the cryptography. We already discussed this one. What is the cipher, and what is plain text and ciphertext, and what is key for encrypting something, or for encryption, or for encrypting something, and what is cryptography and cryptanalysis. Mostly sometimes when we propose a encryption method, we use code breaking or cryptanalysis to make sure that that method is strong, or to evaluate how strong is that method. Okay, the first thing that we discussed, and I already told you this is important for the exam. I told you this is for important for the exam, imtihan. Okay, imtihan, this is important for exam, and imtihan is zaruri for imtihan. It's about the number of key that we use. Some methods, they do not have key, no keys. Okay, some methods, like for example, if my name is Ali, okay, I use an inverse method, I make it ALI. So this is one encryption method that has no key. Okay, some encryption methods, they have only one key. For example, if my name is Ali, instead of each letter I will put the next letter in English alphabetic. So instead of A, I put B, instead of L, I put M, and instead of I put J. So if it's Ali, I can change it to BMJ. Okay, so this is the method that it has one key. The key here is shift for 1. Okay, the key here is shift for 1. Now if you want to shift for 2, for example, the key is 2 shifts. Okay, so instead of A, you should put A, B, C. So this is C. Instead of B, you should L, M, and N, you put N, and instead of I, JK. So it becomes CNK. So this is it, that for the shifting method that I just taught you. Okay, yes, ABC. For the shifting method I just taught you, if the key is 1, it's BMJ. If the key is 1, it's BMJ. Okay, and if the key is 2, it's C and K. Okay, so this is like this. So these are the methods. These are the methods that they have one key. Okay, and when you change the key, the encryption method changes, BMJ and C and K. And there were methods. There were another methods that they had 2 keys. Okay, one key for encryption, another key for decryption. So for everyone like Google, okay, for everyone like Google, we have 2 key. Yes, exactly, Rasha. Private and public. For every entity like Google, we have 2 keys. One is private, another one public. So for the private key, we call it khususi. the key is only for the person. For the public key, we call it امنية. It's for everybody to know that this is public key, but it's for Google. And I told you when you encrypt with I told you about the features, or I already explained the features of these two keys. The first thing was that something that you encrypt with private, you can decrypt or you can open with public, and something that you encrypt with public, you can decrypt with private. And we said that for private of the Google, only Google has. Public for the Google, everybody can have, but they know that this is for the Google. And the next thing which was very important is that when we use the asymmetric keys or two keys, okay, this one, when we use asymmetric keys or two keys, from one side usually we use it for concealment, asrar, I think, or seria. From one side we use it for concealment, from the other side we use for authentication, esalat. Okay, from one side we use for seriyat, from other side we use for esalat. The next thing, we discussed the different methods of encryption. The first one was substitution. Substitution means that we use instead of ABC, for example, I put 1 2 3. So this is the substitution method. When I change the ABC to for example BAC, okay, or like inverse, the previous example or namuzaj that I used for Ali, that one is transposition. Okay, and also we can combine both of them in product ciphers. Just let me see what Saleh says. Actually, Saleh, it's in the next session. I will discuss it. Okay, we use HTTPS. Okay, and it's in the authentication. We will talk about it later. Okay, we'll talk about it later. Okay, and also, yeah, exactly, Rasha. Yeah, I discussed XOR, and I discussed shift and permutation, and then product, which is combination of these methods. Today we will discuss. And then we said that some encryption techniques, they work on a block of bits. Okay, block, I miss, for example, they say, okay, we should have 32 bits, or we should have 128 bits, or something like that. They work on a block. Okay, and then some of them, they only block, I think it's no, not building block, like hajar. Okay, they work like hajar. Okay, in block, but some of them, they work on the string. Okay, they work on the, we say salsaleh, or on the stream of bits. So the block one, it's suitable. The first one it's suitable. Yeah, block and the stream. The block one usually is suitable for all kind of data, but when you have audio, and then you have video, and your data is real time, it's better that we use a string. Okay, it's better that for audio and video, and when our data is real time, it's better that we use a string. So the other one is that it's better that we just hide, we compare whether it's better to only conceal the key, or whether it's okay to just conceal the algorithm, or we conceal both. So we say that for the algorithm it's difficult to keep it secret, so something that we use as a secret, it's only the key. But instead we can trust public algorithms. For example, SSL, and you know what is SSL, and HTTPS, okay, and then also for Wi-Fi, okay, for Wi-Fi, and also for Visa and MasterCard, okay, for Visa and MasterCard. Always for all of them we use known algorithm, or what we say in Arabic known algorithm. خوارزمی معروفه. Yes, thank you, Ali. Okay, for the commercial purposes we use for Master and Visa, Wi-Fi, and then HTTPS. The only thing we don't know, the only missing link that we don't have, it's the key. The key changes, so we say that it's secure. But usually for siyasat, for military purposes, and for countries, okay, milal, they should use their own algorithms. They should invent their own algorithm because it's difficult for them, or it's challenging for them to use public algorithm. Okay, this slide is not important because it says that sometimes when you want to break the code, or when you want to hack a system or want to break a code, sometimes it's that you only have ciphertext. Sometimes you have like this one, ILA, okay, you only have ciphertext. Sometimes you have both cipher and plain text, like this one. For example, you know that the encrypted text is ILA and the plain text is Ali. Okay, so you have both of them. Okay, and sometimes you have access to the system. So when it says, for example, you give Ali to the system, it gives you ILA. Okay, now you can give 3A to the system to see what happens. For example, it gives you 3A, and then if, for example, you give BA to the system and it gives you AB, so you understand what is the method. Okay, you get the key, you get the method. You have you have a text and you get encrypted, and then you use it to see what's on the other side of the system. So this slide is not important. Encryption or computer security is always about the computation, like mining and a blockchain and everything. Well, it's always about the computations. Security is computational. We don't have such a thing as unconditional security, and it's like a ladder and a wall. Bigger wall or taller wall needs a taller ladder. It's something like that. I will explain this one later in the board. So the security is computational. As an example, we say with this key 56 bits, for example, of the key with this computer, it take 1142 Sena to try everything. Okay, but if you change the computer, it's only 10 sa'a, if I'm not wrong. It takes 10 sa'a to test everything. So you see, this is the matter of computational power, or matter of how much power, computational power you have. But there are something here I should explain for you, so it's better I go to the board. Consider that you have a bag. Okay, consider that you have a bag, something like this, and with this one with the lock on it. Okay, you have a bag like this, and there is a lock here. So I put a lock with 3 digits. Okay, you have a bag with lock with 3 digits. So we computationally we calculate. We say, okay, the first number in the digit is 0 0 0 0 0 0, and the last number is 999. What is 9 in Arabic? 9 is Arabic. صفر واحد ثلاث ثاني ثلاث and تسعة. Okay, the last one is تسعة. Okay, the whole numbers, okay, what you have here from 0 0 0 to 999, yes, thank you, from 0 0 0 to 999, it's only 1000 states. Okay, so if it takes me 1 minute for each state. Minute in Arabic, لحظة. Okay, if it takes me 1 minute, واحد لحظة. Okay, دقيقة. Okay, واحد لحظة for each state. So we have here 1000 state multiplied by 1. It gives you equal 1000 minute. Okay, and if you divide it by 60, you will have sa'ah. Okay, or hours. So if you divide 1000 by 60, you will get 16 hours to check everything. So we call this one worst case scenario. Okay, so computationally, to open a bank, miftah or iftah, something like that. Okay, computationally to open a bank, okay, to open a bank, you only need 16 hours. When you don't have the lock or you don't have the password, it takes you only 16 hours to open the bank. This is the worst case. What is the best case? If you are lucky, anyone? Do you know what is the best case? That depends on the luck. No, you just think about best luck. بهترین. The first one is the answer. Okay, so if the first one is the answer, it only takes, for example, 0 0 0 is answer. You check 0 0 0 and then this is the answer. Okay, and it opens. Okay, you're lucky. So this is the best case scenario, and that one is the worst case scenario, and then you will have average or mid. You will have average or mid, which is 8 hours. Okay, something like that, around 8 hours. I don't know what is this, but okay, I will check. Preferred case that's best, not preferred. Okay, that's best. Anyhow, okay. This is the best case. This is the I just use the pointer. This is the mid, this is the best case, and this is the worst case. I just want to check everybody understood what is this, because now I want to explain the concept of computational security. Everybody just put yes or naam, it's enough. Everybody understood what is it about? Hossein, we talk about only one bag, okay? We talk about only one bag with one lock. We call it, okay, security is computational. محاسبات, always you can check everything, okay? And we can call it, in security we call it brute force or dictionary attack, or we call it exhaustive search. Brute force, dictionary attack, or exhaustive search. All of them, they mean one thing. What does they mean, or what do they mean? What does it mean? It means that we check everything. Example is the log of the bag that we put, for example, 3 numbers here, 0, 0, 0. Okay, some of you students said that, okay, repeat again. I will repeat again. So this is the number of the log, and this is the bag. This is the bag. Okay, I will explain again. Consider that you have shanta or shanta, okay, a bag. It has a lock. What is it? What is lock in Arabic? It's qufl, okay, like Farsi. You have a shanta. It has a qufl or a lock, okay. The combination of lock for you when you don't know the lock to open, for considered or assume farz. In Arabic also we use same thing, iftiras, farz, okay? Okay, iftiras, haqiba. What is haqiba? Okay. Okay, suitcase, never mind. Okay, iftiras. Consider that we have a lock with 3 digits here, 1, 2, 3. Okay, consider that you have a lock with 3 digits. So we have 1000 different states. Now if we assume افتراض that it takes 1 minute for each state for me to check 1000 multiplied by 1, it takes me 16 hours to open the case. It's the worst case scenario. It's the الحالة الأسوأ is 16 hours. Okay, الحالة الأفضل is 1 minute. That's the best case. Okay, so the average and the mid, it's 8 hours. Average and the mid, it's 8 hours. It takes me 8 hours to open the case. Okay, so we say computer security is computational. Okay, we say computer security is computational because you always can check everything without knowing the password. You can check everything, and we call this technique, checking everything, we call this technique brute force dictionary attack or exhaustive search. Okay, now I want to talk about something like mining or brute force. I want to talk about something like mining and brute force. Okay, or mining and blockchain. Just think about this one. The worst case, okay, it takes 16 hours. Okay, 16 saat. Okay, it takes 16 hours. Now consider what if I have or I can have 1000 students to help me. Okay, what if I can have 1000 students to help me? Okay, and each test one key. So how long does it take? Consider that I have 1000 students and I give them each of them one key to check if it's possible. Okay, if it's possible. How long does it take? No, Hossein, that's when I do it myself. Exactly, yes, it takes only 1 minute. Okay, it takes only 1 minute because they check everything together. So when you have های 1 دقیقه, thank you, دقیقه واحد, something like that. When you have high computational power or you have distributed system, when you have high computational power and you have distributed system, you can open the logs like this, okay, in a small time like this. And that's the concept when they use mining or they use mining for hash system. The power can be used for decrypting the strong locks, and it's a little bit attack to the security. So security is matter of computation or it's computation. Okay, let's go back to the slide. So you see, security is computational. If you have a strong computer or high power computer, or for example you have access to the grid or supercomputer or distributed system, something that happens in 1000 years will be done easily in 10 hours. So with symmetric keys or in symmetric encryption systems, when you have a plain text, you receive a plain text, you apply the key, and then you get the cipher. So it's the, for example, Ali. Okay, this is the plain text. We apply the key. The key is 1. Okay, we convert it to BMJ. We send the BMJ on the channel. We send the BMJ on the channel, and then on the other side of the channel, we apply the key. Key is 1, and the decryption is, for example, shift -1. So instead of B, again A, and instead of N, L, and then Ali. We go back to Ali. Instead of BMJ, we get the Ali. So the sender, or A, it has Ali. The receiver, this one. The receiver, or B, it also has Ali, but on the internet, the intruders and the hackers or the attackers, they have BMJ. They do not have the Ali. Okay, these are the symmetric systems. Symmetric systems are the systems that you use the key for encryption, you use the same key or same method for decryption. So for symmetric encryptions, the functions can be as follows. Y is equal to encryption of the X with the key of K, where X is equal to decryption of Y with the key of K. Okay, these are the inverse to each other. So the first one that we talk about, the first substitution method, I will give you example for each method, for the substitution and for the transposition or permutation or shift, and for the XOR. For each of them we have one example, one good example. So for example, as a substitution is Caesar cipher. Okay, that we change one. The definition is that we change the letters of one text with other letters from the with the one order. Okay, or with one formula. So we call it روش سزار. Okay, we call it روش سزار, Cesar algorithm, or Cesar cipher, that with the number n, we take number n as a key. Okay, so this n is key, we take number as a key, and then we change the characters with the character that it's we say equal to number after this character. So you can, instead of A, you can put A, we say key or n is 0. Okay, you can change A B with B when the n is 1. Okay, we can change A with C when the n is 2. You can change A with D when the n is 3. You can change A with E when the n is 4, and something like that. So you can change the A with something which is or we can say shift the A, or one letter from the alphabet that its distance with A is equal to that number. We change with that number. So, and the Z, you start from the beginning. As an example, yes, but no key means that the method does not have any key. It's one example. Inverse is one example, only a نموذج. Yes. Okay, it's just one example. Okay, so when you reach Z, you start again from beginning. Okay, that's the thing. So consider, I will write in the notes, consider that n is 3, or consider that n is 2, okay, and I want to encrypt Ali. A after A is B, which is 1, and after that is C. So it's C, L, M, N is N, I, and then I, J, K, okay? C and K. So when N is 2, Ali becomes C and K. Okay, everybody in not in Arabic, okay, in English, Finglish, write your name, for example, like this, okay, and then encrypt it with n equal to 2. Only your name, not family name, okay, only your name. I want to know how you work with the Caesar encryption. I want to make sure that you understood it. Ali, it's easy because I've already done that. Thank you, Ali. Anyhow, what about else? Yes, yes. You need to memorize English letter sequence, and also it's in the slide. No. This is the sequence. Now you can use it. But this is for 3. Okay, this is for 3. You cannot use this one. You just use the part, the first part, that you can count what is next. No. Okay, just do it, everybody. I will for 1 or 2 minutes. Everybody just okay. Rasha is RT. R, okay, T, okay, and A is should be C. Yes, S, U, S should be U. Okay, okay, Rasha is okay. So everybody does it. I will mute for 1 minute and wait for you to do it. Hossein, you used 3, I guess. I said 2. Gassim, V. Okay, Asim, you also use 3. I said 2. I said 2, but here the list is 3. I said 2. This list is 3. Okay, Hussein, HJ. Okay, now it's correct. W, U, W, 1, 2, S, U. Hussein, for the SY, you changed it to G. I think it's wrong. Mustafa, O, M, O. Okay, U, W. Okay, okay. Mustafa is correct. Mohammed, M. Mohammed, you use 3. I said 2. PX, you use 3, Mohammed, like in the example. You should use 2. Mohammed, MP, still it's 3. Okay, anyhow, you make sure that you understand the concept. We will go to the next one. Because this is easy to guess, okay, in this one, because it's easy to guess, because you, for example, if something is 3A, okay, when something is 3A and you change it with 3B, and when something is, for example, ABC, it becomes BCD, for example, something like that. It's easy to guess. So because of that, they usually use numbers, or we call it peymane or mode. Use numbers instead of what? Instead of the characters, which make it more complicated. Okay, the concept is about, just listen, it's about remain there, okay? Or in Arabic, I think you say baqiye, okay? We use the concept of modulation or mode, okay? Or the concept of baqiye. I should go to the board and explain this one for you, because this is also very important. You see, instead of the number itself, we use baqiye. If for you to understand, first, yes, al-baghi min al-qisma, exactly. If we use the 10 as base, okay? If we use 10 as base, you see we have 1, okay? And we have 11, and we have 101, and we have 1001, and we have 21, and we have 51, okay? These numbers are all same, okay, equal. Okay, I will write it here. These numbers are same. How they are same? equal in Arabic مساوي مساف. Okay, these number all are same. Why? Because if you divide all of them, okay, because if you divide all of them, divide by 10, what is the remainder? What is the remainder? Exactly. For all of them, the remainder is 1. Okay, now we can use other numbers like 2 and 22 and 32 and 3002 and 1,000,002. Again, they are all same. Okay, what is the remainder for second one? It's 2. So if I consider that this is my A, okay, and consider that this is for B, and go like this, so on and so forth, something like that. But here, because we use 10 as base, we only have 10 digits. Okay, if we take for example 1 for A and 2 for B, I can use random number. What is random in Arabic? H-O-R-E. Yes, exactly. We can use random numbers for each of them. For example, if something is like this, you see, if something is like this, okay, 4 A's, I can write for example 21, 51, 31 and 01. Now, if I say, okay, what is A, B, B, A? Okay, another example. What is B, 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 A, B, 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 A? It can be 1001. It can be 1000, and for example, it can be 12. It can be 82. It can be again 11. You see, if you look at the numbers, using modulation or using remainder make it difficult for the attacker to understand what is inside. From our view, all of these numbers are same. So this is the same as this one because of this formula. Okay, because of this formula. But from the point of view of the attacker, it's difficult to understand what is A. Okay, cryptanalysis is difficult. What is A? Is it, for example, 21, or A is 11, or maybe A is 1001, or A is 01? It's difficult for them to understand the meaning of A. It make it a little bit more difficult. So in Cipher, okay, in Cipher, I will go back to the slide. In Cipher, we can use the number to change the letter with one letter, which is in. Yes, exactly. All of them are same. Then the number is the remainder. Remainder is important for us. The بقیه, okay, not the number itself. بقیه is important. الباقی مهم. اوکی، الباقی مهم. ليس رقم النفس. الباقی مهم. ليس رقم النفس. Okay, so you can use any number that you want. So you can use any number you want. يمكنك استخدام أي رقم. Okay, أي رقم. Any number you want. Okay, yes. We always use the remainder. So when the attacker look at the number, it gets confused. But you can use any number, any random number. Yes, and you don't need to repeat the number because it's binahaya, unlimited. غیر محدود. Okay, you can use the numbers غیر محدود. But you must make sure that al-baghi or baghiya is same. You can use that in the sender and also in the receiver. Okay, so in Caesar cipher, the first we just use the letters instead of letters. We can shift the letters. We can also use the numbers. When we use the numbers, instead of using the same number, we can use the modulation to the 26. My examples, نموذج لعنة, it was only for 10, but for the characters you should use 26, the mode or remainder of 26. So you use the remainder, it's غیر محدود. Okay, you can use any number you want. Only the condition is that the remainders stay the same. So this is one way. Another way is that also you can use negative numbers for shifting. Okay, you can use negative number for shifting. For example, if you have ABC and with -1, okay, if you have ABC and with -1, it becomes Z, B, and C. It becomes this one. A goes to Z, B goes to A, and then, no, sorry, it's A becomes Z, B becomes C, and C becomes D. Yes, zap, yeah, correct, this one, okay, this one shift to the left. So it's ABC -1, it's correct, thank you, zap, yeah. Okay, so you can use negative numbers, positive numbers, remainders, and everything that can make the encryption more complicated. But the problem with the Caesar cipher is that, if you remember, we said that computer security is computational. Okay, computational. So we can try everything. Always we can try everything. If you want to try everything, here you only have 25 state. Here you only have 25 state, because you can change the A with A, or you can change the A with B, or you can change the A with C, or you can change the A with D, and you can go on until how many? 25 different combinations. How many combinations? 25 different combinations. So that's the problem with this one. The computationally, it's very easy to generate everything, okay, and then see which one is the answer. So instead of that, to make the method a little bit complicated, we can use all of the characters in the English text for cipher. So it's not that the situation is not that, for example, if the A is B, so you can understand, okay, so the B is C. It's not like that. Okay, you can use the combination in any way you want. So you see that this is the cipher or the key here is 26 characters. Okay, the key is 26 characters. Here are 26 characters. Okay, yeah, and you just use any combination that you want. Okay, any combination that you want. For example, you can use instead of A D, but you can use instead of B, for example, Z. Okay, and at the same time for C you can use N, and so on and so forth. So the key is 26 characters. The not bits, bytes may be better. The key is 26 characters or 26 bytes. Okay, and then in the destination you should have the whole key to be able to decrypt the text. So computationally, what is the search space of this one? This is very big. The search space of this one is very big, because for A you will have 25 different with A itself it can be 26. Okay, for the A you have 26 different choices. Okay, when you pick one for A, for B you have 25 choices. Okay, when you pick B, for C you have 24 choices. When you pick something for C, for D you have 23 choices, and so forth and so on. So the combination can be 26 multiplied by 25 multiplied by 24 multiplied by 23 multiplied by up to 1. Okay, what is this? What is this number? No, it's the, I mean the total number. Yeah, it's factorial. Yeah, exactly, it's factorial. 26 factorial is a search space. It's a big number. Okay, so now you can compare. Okay, you in the previous method you had 35 states. In this method you have 26 factorial state. Okay, that one is small, this one is big, so the state is different. Okay, so this is 26 factorial, and then the search space is big, and exhaustive search is time consuming. Maybe we say it's secure. Okay, maybe in Arabic ربما. Okay, so it's ربما آمنة. Maybe it's secure, maybe not. Okay, well, then we will discuss another problem of the security, and that problem it's about patterns. Patterns and namat. Okay, in Arabic, and namat. Okay, and namat. It's all about patterns and namat. Okay, or maths. It's all about the patterns. Language of the human beings and everything. They all have their own pattern. Okay, now let me go to the board again. Consider that, for example, this is your internet traffic. Okay, consider that this is your internet traffic. For example, if big number, I will explain it. Okay, I will explain it. You see, consider that this is the now we are explaining the same thing. This is your internet. For example, when you work with web, for example, if you draw a graph or if you sniff the network or capture the traffic. Okay, if you just use a web, or for example you go to Google and search, okay, your traffic will be, for example, like this. Okay, it's just as an example. Okay, but if, for example, you listen to the music, if you listen to the music, this is like this. It can be maybe like this. Okay, so if movie or YouTube, maybe it's like this. Okay, so the patterns are different from, if you sniff or capture the network, the pattern are different from each other, but same to their own method. Okay, language or lesson, each lesson has its own namat. Okay, each lesson has its own namat. They have their own patterns. For example, in I don't know, in French, okay, you hear re, okay, and je a lot. Okay, for example, in Germany you hear, or maybe Persian, you hear khe a lot. Okay, khe. Okay, you hear khe a lot. Okay, something like that. So from the style or from the pattern, you understand that this is the different language, or which language is that. For the words that we use in language, the number of appearance of the words, they are different, and because of the difference in number of the appearance, you can understand which word is that. Okay, yeah, exactly, which word is that. For example, in English we use e a lot. Okay, e and a and t. Do you know this one about Arabic? Which words, which letter you use a lot in Arabic? I don't know, maybe al. Okay, maybe you use al a lot, or what? Huruful Allah, maybe. What else? Yeah, in Farsi also ye and alef we use a lot. And ye we use a lot. Okay, just take a look at the English. Let's us take a look at the English to see what is it. So this is the pattern for English. You see, E has the high redundancy. Okay, this appears a lot. After that is A. Okay, in English, this is for English. And after that is S. For example, E, A, S, and T. Not S, sorry, T. Oh, E, A, and T. They are the most redundant characters in the English. So if we go, for example, to this text and we just count the numbers, You see, this is an encrypted text. Okay, this is a encrypted text. Okay, if we just count the number of the words that they appear, you can decrypt this one, or you can something like that, or you can break the code just by counting the number of appearance of each word. How, for example, you see that with counting, you see that the P and Z are the most frequent characters appears in the code. So you say P can be E and Z can be T. And then ZW, so ZW is TH and ZWP is THE, which happens a lot or appears a lot in English text. So you can decrypt the text without knowing the key. Here we say no key is needed. No key is needed. So because of frequency of the language, because of the frequent of the language, or because of the pattern of everything, the music has its own pattern, video has its own pattern, Telegram has its own pattern, WhatsApp has its own pattern, and so on and so forth. So because of those patterns, we are never safe with the even strong keys. That's another problem that we have with the security. Okay, so far is enough. I can stop here because the next one is one-time pad and the XOR. You see the next one is this one. It's about XOR. It's better if you don't know what is XOR, it's better that you study before you come to the class. We can discuss it in the next class and we can stop our class here. Okay, if you have any question you can ask until I just take a look at the list and write everything for the class, and then I can dismiss the class. Okay, if no question, you can go. All the best and take care. Wassalamu alaikum wa rahmatullahi wa barakatuh. في أمان الله. شكرا.